So for the Unit 3 test coming up next week, things we need to be able to do. Dilutions. Remembering that a dilution actually has 3 ratios to it. If I give you that we have a 2 in 15 dilution, there are 3 ratios given there. We have a ratio of serum to total. And of course, this ratio is just the 2 to 15. The dilution itself is the ratio of the medication to total, or serum to total. But we also have a ratio of serum to saline, serum to water. That ratio will be what? 2, because it's still the serum, to 13. Very good. And finally, we do have a ratio of water to total, which will be 13 to 15. Very good. And of course, if any of those could be reduced, we would want to do that. We need to be able to do the urine dilution. Let's say we had that sample of where we exceeded the meter, and we took a 20 milliliter sample, diluted with 80 milliliters of sterile water. The reading after that dilution is 187 milligrams per deciliter. So find the true reading. Well, first of all, we have to find what our dilution is. And our dilution is going to be serum to total solution. So what the serum, or the concentrate in this case, is the urine, 20 milliliters. Total, yeah, 20 plus 80, or 100 milliliters. So 20 over 100 is a 1 in 5 dilution. So we're going to use that 1 in 5. Where's the 187 going to go? Well, it is the smaller number. The true value has to be bigger. So the 187 has to go on top because the 1 is the smaller number. And we cross multiply and divide here. What does that give us? Like 935 milligrams per deciliter. So make sure you're able to do that. Make sure that you remember our volume in volume, weight in volume, and weight in weight concentrations. So if I give you that we have a 14% weight and volume solution, how much serum would go into 300 milliliters of solution? Well, 14%, of course, means 14 out of 100, but now we need to put in the units. When it's a weight and volume, the weight is measured in not milligrams, but grams. And the volume is measured in milliliters. And remember, the reason we said for this was 1 gram is defined to be the mass of 1 milliliter of water. So 1 gram and 1 milliliter go together. So 1 kilogram and 1 liter go together. So anyway, that's 14 grams per 100 milliliters. How much would that be for 300 milliliters? And again, you would cross multiply and divide. So this is 42 grams. There would be 42 grams of serum in 300 milliliters of solution. And of course, the other types of concentration as well. We need to be able to do our concentration adjustment. Let's say that we have 200 milliliters of 36% solution. We dilute that to 800 milliliters. Find the new concentration. Well, we could go through all those dilutions to do it, but all we really need to do is this. Concentration 1 times volume 1 equals concentration 2 times volume 2. So we have 36% times 200 milliliters equals that new concentration times 800 milliliters. So you're going to multiply this out. 36 times 200 is 7,200. And you're going to divide by 800. Because the new concentration is 9 or 9%. Is that all looking familiar so far? Okay. And of course, you need to be able to do dosages based on weight, like we did to start the hour and to end last week, based on body surface area, so if I give you, 2 grams per kilo or 2 milligrams per kilogram, how many milligrams need to be administered? Our IV flow rates, finding it in milliliters per minute, milliliters per hour, drops per minute. If I tell you that we are going to infuse 150 milliliters in 20 minutes, how many milliliters per hour is that? Well, that's 150 milliliters over 20 minutes. And I'm going to just convert that into hours. So times 60 minutes in 1 hour. Minutes cancel out. It's 150 times 60, which is 9,000 milliliters in 20 hours. We divide that out to get 450 milliliters per hour. You have to be able to work that formula backwards. If I tell you that the current flow rate for a patient is 40 drops per minute, and it's a medication that had a drop factor of 10 drops per milliliter, and I'm going to ask you, how long will it take to infuse 800 milliliters of fluid? We're going to have to work backwards here. I'm going to start with my 40 drops per 1 minute. Now the time is on bottom here, so that might cause us problems. We want the time. We're trying to find time. We're trying to find, let's say I want this in hours. So since the time is on bottom, that's telling me that might not be the place to start. So I'm going to cross that off. Let's start with milliliters and see if that helps us. 800 milliliters. Put that over 1. First thing I can do is use my drop factor to get rid of milliliters. 10 drops per milliliter is going to tell us that this is 8,000 drops. The milliliters cancel out, so that's 8,000 over 1. And now 40 drops per minute. I'm going to get rid of my drops. The 40 drops are going to go on bottom, so that the drops cancel out. 1 minute on top. So the drops cancel out. That's going to be 8,000 minutes over 40. which is what, 200 minutes? And then I just have to convert that into hours. I'm going to divide by 60, which will give us 3.33 hours. I know I got lazy on that last step. I didn't use the conversion factor to go from minutes to hours. But I'm assuming you guys have done that one a couple of times with it. Let's see if there's anything that looks unusual on here. I'm not going to try to do any lecture after the test. Some people, I mean, typically on this one, there are some people that fly through it. I've had people gone in less than 30 minutes, but I've also had people sit there that needed extra time after the 2 hours. So I'm not going to pressure anybody to get done. Make sure, by the way, that you are familiar with grains and with fluid ounces. We did some examples in the last couple of weeks with those in there. You may want to look back over those. The fact that 1 grain is how many? Do I remember 1 grain is how many milliliters? Or milligrams, I should say. Not milliliters. I know it's 60 and 15, but it's Friday. I can't remember which is which. One grain is 60 milligrams. 1 gram is 15 grains. Now, I put these together. Don't confuse it. When you in the test, a lot of students see GR and they think gram. GR is grain. Usually to be listed, grains are usually listed with Roman numerals. So you might see GRX, which would mean 10 grain. Okay, I think that is all the information you really need to know. Anybody have any questions? There are pages in the book. Just kind of finishing up. I don't know if I had recommended page 184 to you last time. 1 through 11, the odds. Page 190, 1 through 21, the odds. And page 196 through 197, 1 through 19, the odds. One of those might be review. Okay. The safe dosage stuff is on page 190. That's one that the students tend to struggle with quite a bit, is getting that safe dosage down. Because you have to figure it out from both ends like we did. You have to take the doctor's orders, then you have to take the recommendation off the bottle. Any questions? Okay, you guys have a great weekend. We will see you next week for the test.